to Vegas programmers, aka Las Vegas developers, formerly known as PHP Vegas. I think I lost my breath from saying that, but our meetup's been around for 6 years, 5 years? I don't know.
More than 6.
Yeah, a long time. And basically our goal is to share our knowledge, and not only with new people to programming, but also the veterans out there that always get that little tidbit of information from any topic here. So today we have someone very special lined up, Cody Moss, one of my dear friends who I've worked with in the past. Very, very smart, talented individual. I've voluntold him to give this workshop that you're going to see here today about Kubernetes. Who here has heard about Kubernetes? Who here has no idea how to use Kubernetes? Okay, so it's aimed at both of those people that raise their hands. Basically, this is going to be a mini version of the longer format workshop that we're going to have later next month. So unfortunately in this one, Cody's going to be zipping through a workshop that he's built where he'll show how to use Kubernetes and all of its wonderful features. If you want to actually get this working on your laptop and have a deeper understanding of how Kubernetes works, I would invite you to go to meetup.com/VegasProgrammers, look us up there. And I haven't posted it yet, but June 24th at a co-working space, we're going to have a 3-hour-long workshop, 2 to 3 hours, where we will do a deep dive into Kubernetes, where Cody and I and a few other individuals from the meetup are going to be there, and it's invited to everybody. It's a free workshop, right? Again, we're not asking for money here. We're just here to share knowledge, meet new people, and bring up the new people in the community to learn as well. So at the end here, let's talk about topics for the next Tech Alley and stuff like that. I also have some free JetBrains licenses to give away here at the end too for anybody who wants one. Yeah, anything else I'm missing, or is that about it? We're good? Okay, cool. All right, let's kick it off. So here you go, Cody.
So thanks, Josh, for the introduction. I don't actually have an introduction slide because there's just so much we're going to have to cover. So if you guys have any questions, you'll be able to find me over at Javerna after this. I'll be there until probably sometime around 6 or 7 o'clock tonight. So if you have any questions, you know where to find me. Also, this entire workshop, all of the code can be found on my GitHub. These slides will also be linked to today's meetups page. So you'll be able to actually click that link and go right to the code base. Okay, so the tools you're going to need for this workshop, luckily I've already set them all up on my laptop, so we're not going to be watching me install and download and all that fun stuff. But if you come to the 24th, this is like stuff you'll be working on hands-on. So first of all, you're going to need Rancher Desktop. It's a drop-in replacement for Docker Desktop. I actually highly recommend it for just kind of everyday use, especially if you're having trouble with the new Docker Desktop licensing. Theirs is MIT licensed and completely free for use. Then you have Tilt. That's something we're going to use to kind of simulate a refreshing local dev environment, because anytime you're working with local Kubernetes, one of the pain points is usually people are like, well, how do I get it so that every time I make a code change, it just automatically deploys to my local cluster? Well, Tilt's that answer. The first time you ever spin up Rancher Desktop, you're going to get this lovely prompt. And you're going to notice that there is 2 APIs you can pick from. One is Container D, and one is Docker D, also known as the Moby API. You're going to want to pick Docker D right now because Container D, although that is what you're going to run on servers and it's very well supported, user space, not as much. So even Tilt is having problems with it, or if you want to use Kind or K3D or some other thing to spin up multi-node clusters locally, you're going to have a hard time right now because Container D's API, although well supported by server software, is not supporting user space. Okay. Rancher Desktop is also kind of neat because it comes with all the other tools you need. It comes with a single node Kubernetes cluster that's spun up with K3S. It comes with kubectl, Helm, and a couple of other neat tools. And also you'll be able to build Docker images with it and also deploy those to the local cluster. Okay, so it's kind of hard to talk about Kubernetes without talking about pods first. Pods are the smallest form of a workload. I'm getting ahead of myself there. So it's the smallest thing you're ever going to deploy to a Kubernetes cluster, though you're rarely ever going to deploy it by hand. Mostly because they are ephemeral. And if you ever deploy it by hand, what's going to happen is if anyone ever deletes that pod, or if Kubernetes decides it wants to delete that pod, because sometimes it does that when it goes to move workloads around on the cluster, well, if you don't have anything controlling it, it goes bye-bye. It's gone completely. And you're never going to get anything back from it, other than you can spin up another one with that same container image. But that's also the neat part is pods can also be made up of more than one container. So they are more than one container. So you have init containers, you also have sidecar containers and other various things. Sometimes maybe your application needs two containers like PHP, you need an Nginx or some kind of web server in front of it, and then you also need your PHP runtime. Luckily, when they are all in the same pod, they all share the same network, so they're all communicating on local hosts. So if you ever want another container to talk to another container, if they're in the same pod, you just go to localhost at port, and then ta-da, you have communicating containers. Okay. So let's actually go ahead and run a pod. Exciting stuff, I know. You get a line of text. But what you actually do, now if I go ahead and run kubectl get pods, on my local Kubernetes cluster, I now have an Nginx pod running. Though it's very useless to me right now because I can't actually get to it. So there's a couple of things with exposing pods. You have a couple of different varieties. You have no port, which is on all of your Kubernetes nodes, if you make a no port service, what's going to happen is it's going to spin up a random pod or a random port between like 3,000 and like, or no, it's like 30,000 to 37,000, somewhere around there. And so that port would be open on all of your nodes that would go straight to that pod. The other one is load balancer. Although when you're spinning up with load balancers, this is where the cloud comes into play, because usually you need a cloud controller to actually spin up a load balancer, or it's not going to really go much of anywhere. But luckily with K3S, it actually comes with a really neat utility. So it actually will, if you say load balancer, it will actually spin up a load balancer with a node port locally, so that way your configuration will still work across the cloud and also your local environment. You also have cluster IP, which is headless. This is useful if you're trying to expose a pod to only internal traffic inside of a Kubernetes cluster. So whenever you're inside of a Kubernetes cluster, there's the CNI, and what's going to happen is all of the pods can kind of talk to each other, but they have to know where to go. Because since their IPs can change all the time, what you're going to actually do is spin up a service with cluster IP or even node port and load balancer. They do end up getting cluster IP, so you can still communicate internally with those. And what happens is the service will always stay put, and it will always maintain that cluster IP. So even as pods come and go, the IP will remain static for how you connect to those. But you should also just use the DNS to look up, because service discovery Kubernetes is very hot. Another thing you could do is you could just circumvent the service entirely and do what's called a port forward, or you do kubectl port forward and you like give it a bunch of flags, and then you end up with just a port on your local box straight to a pod. This is useful for debugging, especially if you're like, is my pod the thing that's not communicating, or is it like something else along the chain, right? So we're actually going to go ahead and get started with workflow. CLs run, that Nginx name right after it, that's the name of the pod. So now I have this port forward, and it's port forwarding a local port of 8080 to port 80 on the pod. So if I go to my web browser, for some reason I don't have an address bar that I'm supposed to, so we'll just go ahead and do that. I get this lovely Nginx default page. Very exciting stuff. But yes, so now I'm communicating straight to the pod. And we can see that if I go here, it says that it was handling a connection for 8080. And what that does is it takes 8080, communicates straight to the CNI, and goes right to the pod. Control C out of that, just like most other Unix commands, and then we'll get your shell back. Okay, the other option is for us to do expose. So what expose command does is it actually generates a service for you and it configures it with the various types. And you can also then ask like which port on the pod do you want it to actually expose, which in this case instead of Nginx, when we're not doing anything TLS, we want it on port 80. Okay, now we have a service that is exposed. And you can get that same information by just doing kubectl get service. Okay. So I see I have a node port here that's also named Nginx. I can see that it has generated a port for me, which is port 80 is what's going to on the pod, but then that colon 32478. If I go to localhost 32478, what's going to end up happening is I'm going to see that same Nginx default page. But it's because what's happened is it opened up that port. Since I'm on a single node cluster, it's on my local machine here, that's why I'm going to localhost on that port. If I was doing this on a remote cloud, I would put whatever the name of my cluster is, like some FQDN domain name, and then at the end I would put colon, 32478, and then I would get that Nginx page. Service. I already talked about that. Okay, now that we want to get with like some actual stuff going, it's actual application, not just a default Nginx page. Let's go ahead and delete some pods. Deleting a pod, and now if I were to do get pods, it's gone. But then get service, I still have my service, so I still have my node port. This is one of those handy things, right? Because like a lot of people, or a lot of network people were probably like, oh, but if I delete the pod and the workload goes away, doesn't that generated port go away? As soon as you make the node port, it's going to hang on to that port for as long as this service exists. If you ever delete the service, the port's going to go bye-bye, and you're going to have to tell everyone to take the port. It's a very bad day. I wouldn't recommend it. That's why most of the time I'm going to say, you're just going to want to do load balancer, because it makes your life much easier, and then it's just a domain name. And also, your coworkers won't hate you when you accidentally delete it.
described you. Maybe I missed that.
Okay, so describe. I missed a couple of that thing. I thought I already went over that. So what kubectl describe does is it actually takes that type and then it takes the resource name and it will actually dive into it and it will grant you a lot more information. In this case, I've already deleted the service, but the way that service works is since they are decoupled, it has to have a way of finding the pod. So there is what is called selectors. And so when I spun up the pod, I gave like a command of -- labels, and I gave it a couple of labels. So when I actually did the expose command, it automatically detected those labels and added it to the service so that it had the selector look for those labels. And it will find any pod across the whole cluster that has those labels. And that's how it actually found it to know how to connect to it. You can also do describe on a variety of other types, like you can do it on pods, you can do it on deployment stateful sets. We'll be covering a lot of those here shortly. But it just is a great way of getting more information when you're like, what is this thing doing or how is it configured? You should just always describe it and it'll grant you more information. I'll describe something here in a moment and we'll take a look at it. Okay, so local development starter, I actually have that as just tilt up because I already have tilt installed. So part of tilt is when I do tilt up, it's going to grant me like a web interface and it's going to spin up like my entire stack on this Kubernetes cluster. In this case, it's just two applications. One's called the dashboard, one's called the application. We're going to mostly focus on the application for right now, but later on in the talk, we will actually go over the dashboard and show like how it's going to show the difference between a development environment and a production environment that are also running on the same cluster. Okay, so with tilt up, so I realize it's probably very hard to see. So with tilt up, what happened is it started its daemon, and then it went through and found the tilt file configuration, and now it is trying to spin up the workload, which appears to be dying for some reason. So we can go in and figure out why. Oh, because I jumped ahead of myself. We're supposed to create a namespace called that. Okay, so I guess this is going to be a good time to cover namespace, especially while we wait for the workloads to attempt to spin back up as I'm going to trigger them again. I should go on dashboard times. Okay. Okay, so Kubernetes has the idea of namespaces. So if you're familiar with programming, it's a namespace is just a way of like classifying your modules away from other people. So if you happen to have like the same names on your objects, they're not gonna smash into each other. You're not gonna have collisions because you can just give a fully qualified namespace to it. In this case, so in this case, it is a way of classifying all of the Kubernetes resources away from each other so that they can be named similarly, and you're not going to end up like, if I spun up app in dev and then I spun up an app in production namespaces, they're not going to collide, though the labels might still collide because of the way services find pods and other things find pods. So be careful on your labels. You should just always add your environment or hell even your namespace into your labels, so that way you really just don't have any collision. There, now everything's all green, check mark, happy with it. Okay, so what just happened, kind of cover all this. So we used the tilt file, and then we had Kubernetes object configuration files. So those configuration files are being generated using something with Helm, called Helm. Helm is a package management tool. We're going to cover that more in depth later. So Kubernetes object configuration files. So everything in Kubernetes is an object, or what we also call as a resource. Those terms are kind of interchangeable when you're talking Kubernetes. So you're going to have like your service, you're going to have your pods, you're going to have your deployments, and you're going to have other various things, especially as Kubernetes comes pretty bare bones out of the box. As you go down this rabbit hole, you're going to quickly discover that there's a lot of tools you can install in your Kubernetes cluster, and they almost all come with CRDs, which is a custom resource definition, which means you end up with a lot more resources. So my Kubernetes is likely not going to be the same as your Kubernetes, unless we're both running like just straight install off EKS, AKS, or any of the cloud ones, and we install nothing else. So, and also with the file, it has already spun up, and if I were to go to http://127-0-o-slip, we're going to see the application running. And then here is the JSON response we were getting from the API that is located inside the Kubernetes. So, a couple of things. Yeah. Let's go ahead and take a look at some of those config files, shall we? I'm going to go ahead and type in the list so that way it doesn't just all scroll past the screen. So here is what Kubernetes configuration looks like. It's just a bunch of YAML files. Almost all of it's almost always going to be YAML files. In this case, we have a service account being made, we have a service being made, we have a deployment being made, and we also have ingress being made. Okay, so let's cover a couple of these different resource types. So going back to the beginning, when I said that pods were ephemeral, the smallest form of workload, you're never really going to spin up pods on your own unless you're really just testing one container for a very short amount of time, or maybe you're trying to debug something, and you're spinning up a pod so that way you can kind of go search the service discovery, which is just DNS requests inside of Kubernetes. And you also have, what do you call it? You know, you can also have it where you're trying to communicate directly to a headless pod to see if it is returning what you think it's supposed to be returning. That's the only time you're ever going to spin up a pod. Otherwise, you're probably going to spin up a deployment, stateful set, or yeah, that's actually pretty much it nowadays. So what a deployment does is it will take this. So first of all, every Kubernetes configuration has an API version, a kind, metadata, and a spec. This is the spec for the deployment, which has replicas, the selectors, because again, deployment has to be able to find the pods so that we can manage them. And then you also have where it's going to have these security contexts and what containers are inside of it. That's all a template. If you notice at the very top, I'm sure it's hard to read, but there is a template right under selector labels. And what that is, it's templating out a pod. Because what a deployment is going to do is it's going to become a controller. It's going to spin up your pods for you, and it's going to make sure you have the same number of replicas you can tell it to run. So as Kubernetes decides to, like, oh, I get disk pressure, or maybe I'm getting CPU pressure or something like that, and it's like I need to move some of these workloads around because this node's getting overburdened. How Kubernetes moves things is it spins up a new pod elsewhere, kills that last one. But if you just have a pod running, it just kills that last pod and never spins up the new one because the scheduler's like, I don't know what you're talking about, bro. And so in this case, with the deployment, always going to be running, in theory. Then going back up here, we have our service. So again, it's just like what we were looking at before, except for in this case, it's a more broken out fashion and a repeatable deployment form, because this configuration is going to, when you apply it to the cluster, this is something you can commit to your code, right? You can commit this into your repository, so it's a repeatable deployment. And in this case, it's a cluster IP, which earlier I said cluster IPs are headless, like nothing outside of the cluster can get to. Well, that's where ingress comes into play, which is this lovely object here. So ingress is, you have an ingress controller that 9 times out of 10 gets installed if you're spinning up Kubernetes on the cloud, AKS or EKS. They come out of the box with an ingress controller of their own. Now, if you're trying to run, bare minimum Kubernetes, you're going to be installing it yourself. Rancher comes with a pretty nifty one called Trapiq. It is it's inside the cluster, comes out of the box, so you don't have to worry about configuring it. All you have to do is worry about configuring your ingress. So in this case, its spec looks like a bunch of rules. In this case, I'm saying that if host name comes in of 127, blah, 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 and it's coming in on path /, which means everything, because I have my path type implementation specific, which means to send everything. And it's going to go to the service of release name @demo at port number. And so since the ingress controller is inside of the Kubernetes cluster, and I've now configured it, that's how come we can hit our headless service. If it seems like we're going really fast, it's because I am. We only have 45 minutes for this one, really, June 24th. We're going to be doing a lot of this hands-on, together, and moving a lot slower. Helm charts. Okay, so this is where the fun kind of comes into play. So they are templatized Kubernetes configs. They can be very reusable, especially because if you just do Helm create, if you really have nothing besides expose port 80 and set up ingress, you can pretty much use that one Helm chart for all of your workloads. Of course, with other values configuration files. The packages are also called charts. So if you're ever asking someone hey, do you know which package I need to install? It's more, what chart do I need to install? Because we like to keep a canonical theme, especially with Kubernetes. Also, there's a bunch of community maintained charts there in Artifact Hub. If you're ever trying to spin up something that's very well known, it's open source, like MySQL or so on and so forth, it's there. You can spin up MongoDB, Kafka, everything. You just go to Artifact Hub, find the chart for it, find the configuration you need to do for it, because your configuration is going to be slightly different usually. And then after that, you pass in, you set up the repo on your local or on the server, and then after that, you just kind of do Helm install, the name you want to give your deployment, the chart, and then you do -f, and you point it at the values file for the configuration you're changing, and then ta-da. You actually will have Kafka or something else. Pretty good. Okay, so Tilt is great if you're doing local deployments because it will watch the file directory, and as you're changing the Kubernetes configurations or your Helm chart, what will end up happening is it will it'll watch all that, and then as you change it, it just automatically builds your container and pushes it up to your Kubernetes cluster. So in this case, let's say we wanted to if we wanted to spin up a production environment. In this case, I'm stuck with one cluster on a local box, so we're going to namespace it, and we're going to treat it as if it were production. Also, here's a couple of URLs you'll need to go, dashboard, and then we're going to set up a dev and a production pane, and the production will be found at prod dot the same pane as dev, except for it's on subject. Okay, so now I have two panes. One is dev and one is production. You can see production is down there. We're very bad at starting at this point. Okay, so first things first, we're going to have to build our production container. Just your normal everyday Docker build command, which ran excruciatingly fast because I had most of this already cached. Because demos are fun and can sometimes break, especially when you have black internet. So in this case, it just built our application, and it is what do you call it? It built the application, and we're going to pretend that we just pushed it up to a registry. And when you're working with a remote Kubernetes cluster, you're going to need something to hold your container images. In this case, since we're working locally, anything we build on our local runtime is automatically exposed to that local Kubernetes cluster. Now let's go ahead and deploy it. Namespace. Now this is a helm upgrade. Let's actually go ahead and put that up top. So I have helm upgrade, the name of my deployment, a directory to where my chart is, because since it's a local chart, I don't have any HTTP // look for this part TZ or use repo magic. And then I'm doing -- install, so that means if it's not already installed, it will install it, because Helm is particular about that. You usually want to do Helm install for the first time and then Helm upgrade after the fact. I'm too lazy for that, so I just always do Helm upgrade and pass that install flag. After that, I give it a namespace that I want it to deploy to, because in this case, I don't want it to want my dev environment. I want it to be a little bit of separation, right? So I'm going to pass that -- namespace production. And then I have a different configuration for my production than I do my dev. This is a pretty, usual use case. So you do -f. In this case, I stored it in the same chart directory, but I called it prod-values.yaml. I would really love to go into detail on those. Maybe if we have time at the end, Josh hold me up to that, and we'll kind of go more in depth in that. But what it's doing is just kind of setting an environment variable and setting the ingress to be slightly different, so that way we have the prod.rest of domain name will be our production, and then our output of JSON will be different because it's a Go application and it's looking for an environment variable. In this case, you can pass environment variables into your pods, or you actually pass it directly into the container. And in this case, it should change the JSON output. That was awfully very fast, but that's because it didn't have to download anything. If we were doing this on a remote cluster, this would have taken a bit longer, because it would have been okay, is the deployment coming up? Is this coming up? As it's downloading that container image from your container registry. same version, but one says hello Vegas programmers and the other one says hello production. We already did that. Created a namespace. We'll make it forward. And our dashboard should now show production running, which it did. And that's the part where I would like to thank you all for coming. But if anyone wants it, we can go more in depth if there's any questions.
Do we have any questions? I know I do. Okay.
Go for it, Josh.
So, two things. One, you mentioned environment variables, and I'm curious about the production stack. What's like best practice to manage secrets in this whole? Because I thought Kubernetes had something that's like a secrets manager or something like that, but I've heard mixed things about that. And then I'm sure people just use environment variables and probably inject secrets that way too. So what's like a best practice there?
So the best practice I'm going to say is be very careful with your RBAC because Kubernetes comes with RBAC out of the box. Secrets are just base 64 encoded values. So not encrypted, but also not plain text. It's security through obscurity. But it comes with a slew of RBAC protections and basically like be very careful when you grant service accounts, things like that access. Secrets are also namespaced, so they can only be accessed if you're within the same namespace or if you're doing kubectl commands. Now, the best practices that I employ a lot, and also I've seen the community kind of speak about it as well, is especially if you're in a cloud environment, you just use the like AWS Secrets Manager or the Azure Key Vault. I don't know what Google Cloud has, but I'm sure they have something because they're going to come with a controller installed that will inject the secrets for you and it manages them so that they become injected as Kubernetes secrets and then your deployment configuration in either your environment or as a volume, whichever way your app wants it, as a file or as an environment variable. You can say that, hey, I want to pull in this secret as like a secret reference, give it a name, give it which key you want, or a list of all the keys, and then it will inject it into your pod. That's kind of the way you do it, especially because if you're in Azure, AKS, it will only inject the secret from Key Vault as your pod is, deploying out. It goes, oh hey, I know it's going to need this, so it makes the secret then. And as your pods, get deleted and stuff, it will just automatically clear the secret out. Secrets Manager, they tend to just kind of make it and leave it for as long as your deployment's there. So do with that what you will. I kind of prefer the AKS method, but if you're stuck in AWS, you're kind of stuck in AWS.
What's RBAC?
Role-based authentic or role-based access control. That's it, not authentication. It's access control. So earlier, our Helm chart was making a service account. Service accounts. So every pod gets a service account. If you don't specify one, it gets one that's named default in the namespace. And basically, that service account, even if you generate one, has zero access to anything other than to exist. And if you, and also any other configuration you put in the deployment, right? Because we say, hey, I need you to go get the secret. It will go get the secret. Since secrets are namespace, you can't go cross namespace though. That is locked down. But so when you spin up your service accounts, if you need to have like a higher level of access, like maybe you're making a Kubernetes controller or an operator, because some of us really love automation, you would create either a cluster role or a role. Cluster role is cluster wide, role is within a namespace, and you would do a role binding or a cluster role binding to say that this service account has these roles. And then those roles are what we're granted to be able to deploy other deployments or deploy other things inside of the Kubernetes cluster. Maybe you can read certain data or it can't.
And then my last question was the difference between dev and production in this case. Like, were they just basically two completely different charts? Or, you know, I've dealt with this a lot too, where like I basically have like a dev Docker setup, like Docker Compose, right? Docker Compose YAML for my dev, and then a Docker Compose YAML for my production. But like, I guess what would be the ideal situation is if there was some sort of inheritance structure where, you know, either dev sat on top of production's configuration or vice versa. So how did you set this up, or I guess what's best practice there for having a chart for your dev and production?
Okay, so here's all the code. I have this one application. It's just, you know, to go out and talk about. And here's where it does like the message stuff, and then it just prints it in. And it always returns version 1.0. There's the tilt file of the Docker build, but you can see I'm using the Helm chart in /chart for the dashboard, dev, and also earlier when I ran the command, that was production. So it's all the same Helm chart, which is pretty handy. Now, Helm charts have this values.yaml. It's not very long. You can see that it has like a count, image, in this case, this is what I changed, and a couple of other things. This is where you can store any of your values inside of a Helm chart. These are all the defaults. Now, when I did like that -f at the end when I was deploying production, it was deploying this values.yaml, but if you notice, it's significantly smaller. And that's because what it's actually doing is it's overlaying this values on top of the other values. So basically, if I don't mention it, it's going to take what was default in that values.yaml, and in this prod dash values, whatever I changed is what the new value is going to become. So in this case, it was all the same Helm chart. And then this is where I was setting the message. And dashboard is the other application that my buddy Rob Cox, he wrote for this because he's helping with the workshop. He couldn't make it today, so I'll have him speak to that on June 23rd. But it's just basically an OJS app that, you know, creates that user interface and makes it so that you can inject a bunch of URLs and just watch data. And then here is the Kubernetes cluster running. This is a tool called K-Nice. And I highly recommend it, especially if you're in Kubernetes, basically turning your Kube cluster into Vim. So if you really like Vim, you already know how to use this tool. But as you can see, I have dashboard app demo, that's a pod that's running, because this is showing all my pods. And then I also have dev app demo, and then the two production pods, because in the production config you saw that I set the reference to 2 instead of 1. So I get 2 pods instead of 1 pod. And then what ends up happening, but what we actually deployed mostly were these deployments. And you can see where it says like the number of ready pods. But they all end up becoming the same. You will see that they get a certain set of labels or annotations where it says that this was basically deployed by Helm, or managed by Tilt in this case. Tilt rejected that instead of Helm. Also, what I just did was YAML, because if you do like kubectl get like the deployment name, and do like -o YAML, you get the same output except for without the Chrome. And if I wanted to describe, I press D, and this is what you get when you describe stuff too. Again, just without the Chrome around. Okay, Kubernetes is a really neat tool for visualization.
And can you use this against like AKS or EKS or like other remote, like to visualize the production environment? Could you somehow connect this over there?
Yes. So kubectl has a bunch of it has like a config file, and you can put it in a lot of clusters. I actually haven't hit the limit yet. I'm at currently 50 clusters I manage. It's a lot. And yeah, so all of these can work like that, especially if I go with context. Because in this case, I just have Rancher Desktop. This is the only one I manage here. When I say 50, it's for a bunch of other clients. I'm not going to show their configurations here. But it's in home/.kube/config is the file. Just another YAML file. Kubernetes really loves YAML. So if you're using Kubernetes, I hope you like YAML too, or you're going to be a salty person. And so you say what the cluster is, what its endpoints are, and then you have another section for what is your user, and then that will also set the authentication method. EKS has OIDC, AKS also has OIDC, Google Cloud, if I remember correctly, they're still doing the cert-based authentication where it generates you a cert. It's signed by a certificate authority. Basically, anyone with that authority can log into the cluster. That's actually how most on-prem clusters also work. And so this configuration file looks a little something like. In this case, Rancher Desktop you see is doing certificate authority based. So you see the cluster and it says it's all 127.0.1 at port 6443. I'm cool with showing you this because it's on my mobile. Not to mention if I really want, I can just reset it and insert changes. And my user is client certificate data. That's just a base 64 encoded of the what do you call it, of the cert, and also my cert key because it does have a TLS to know that you belong there. Because if you just have the cert but you don't have the cert key, it still doesn't work. And then you have your context down here. My current context is set for Rancher Desktop. This file changes every time you do kubectx config set context or use context. So use context, set context will generate a new context in this file. And then what that does is whenever you say the context, it has the cluster, the name, and the user for all of that. It links that data all together so that way it knows how to authenticate.
Can you just pull up your GitHub and then we'll wrap up?
Yep.
So if you want to see the workshop beforehand, this is where you can go here. Was it Code Glue Kubernetes workshop? So yeah, if you probably search for Code Glue, this is probably a start project underneath it or something.
I probably should.
Yeah, so it's
haven't
there.
been there yet.
Yeah. But
if you just Google, you will find my GitHub and we're at the 30 plus. At the end of today, it will be pinned, I promise.
if somebody wants to get a hold of you, other than carrier pigeon.
Okay, so it's going to be Twitter at CodeBlue, and then Discord is. I'm trying to remember what my last digits on the end of my name was.
Yeah, they are.
They're removing those in a couple of weeks. So.
Are they?
Yeah.
Well, what are they going to do with username collisions then?
It's
First come, first served.
CodeBlue hashtag 1067. And I hope I am whoever said that, yes, they are getting rid of those numbers. And I'm hoping I'm part of the first group because I really don't want people to take my name.
I doubt